Hello folks, we come back with one more episode of the video of this new chapter 6. All this time we were doing chapter 5. Chapter 5 was continuity and differentiability, but this new chapter, it is application of derivatives. There are 5 different applications of derivatives. So for that we have got 5 exercises and 1 miscellaneous. So that's how the chapter is. It's another important chapter. Calculus, it's a part of calculus and carries lots of weightage in the exam. So there are 5 applications, as I said. The very first application that we're going to do today is rate measurer. So it's a simple application. So rate measurer is what we are going to do. Quite a simple application, as I said. So let's get started. It's the exercise 6.1 and we are doing the first question. The first question reads like this. It says that find the rate of change of area of the circle with respect to the radius r when r is 3 and r is 4. So we can read the question carefully. Rate of change of area of a circle. So it is the rate of change of area of the circle that you have to find out. You have to read the question carefully, then only we get to know many things there. Rate of change of area of the circle with respect to the radius r. So this with respect is important because that's how we'll come to know that we have to take the derivative with respect to what variable, that way. So if they say it is with respect to radius, means you have to find out the area, get the derivative with respect to radius r. So that helps you to find the derivative. Some cases where they don't say, that time it would be with respect to time. So depends, as we'll come across all the cases where we will see how we have to find the derivative. Now it's very clear to us that we have to find out it's a circle. You have to find out the derivative of the area with respect to radius r in 2 cases. Once when r is 3 centimeters, radius is 3 centimeters, and in the next case when the radius is 4 centimeters. That's our first problem. So let's get started right away. We all know that let A equal to pi r squared. We all know that area of the circle is pi r squared, where A stands for the area and r stands for the radius. When if at all need be, if it's a big question, it's like as I told you, it's a long question, then you should mention where A is the area of the circle and r is the radius. Normal questions we generally don't mention, but if it need be, depending on the problem, you should mention it. Okay, so they tell us now to find the derivative with respect, rate with respect to r. So let's find the derivative with respect to r on both sides. The derivative of pi r squared, pi is a constant, so no derivative. R squared with respect to r, we all know that it is 2r. So therefore it is 2 pi r. So we are getting dA by dr to be equal to 2 pi r. Now that's it. We are done. Now we can just substitute the values and get the answer. They have told us that first case it is 3, other case it's 4. So that's it. So in the first case, radius is 3. So what is our dA by dr? It is going to be 2 pi into 3, which is 6 pi. So also in the second case, radius is 4 centimeters. So what is our dA by dr? It is 2 pi into 4, which is 8 pi. So that's it. It's as simple as that. Generally, it's asked for a 1 mark question or maybe 2 mark, or like depending on this. That's how it is. Quite simple. And that's how we do it. So let's go to the problem number 2 and let's see what the problem number 2 says. In the problem number 2, they say that the volume of the cube is increasing at the rate of 8 centimeter cube per second. So we are talking about the cube and they say that the volume is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when the length is 12? So first of all, many things to note. First is that it's a cube and they tell us that the volume is increasing at the rate of 8 centimeter cube per second. They tell us to find out the rate of increase of surface area. They ask us to find out how fast is the surface area increasing when the length is, suppose if we call length as x, length is 12 centimeters. That's a question. So from we have some information about V. From there, you have to get dA by dt. That's our question. That's a cube. Nothing new to us. We know everything. That for the cube, the volume, if x is the side of the cube, suppose say let x be the side of the cube. As I told you, depends on the question. If it's a big question or it's a long answer type question, you have to mention everything. But if it's a shorter question, things are understood. If you can draw a figure, then in the figure you can directly indicate what these are. That's all one's own convenience and one's own way of attempting the question. If you want everything foolproof, that you will not lose marks, then you should attempt your question accordingly, but you have to keep track of the time. Sometimes what children will do is they spend a lot of time in 1 mark and 2 mark questions, 3 mark questions, and they fall short of time in the bigger questions. That should not happen. You should be very judicious in the way that you attempt. Everything should be there. For example, if you draw a figure, if you're very brisk at drawing figures, for small questions, need not take a pencil. With the pen itself, you briskly draw a figure and indicate everything there, so that it cannot be told that the examiner cannot tell that it's not clear, like such things. So you have to be very judicious in your way of attempting with perfect track of time. That is most important. You have to keep track of time. Say by January onwards, you should be attempting so many papers, so that you can keep track of time, and every time you do, you will improve yourself. You should improve yourself that way. And total commitment. You don't require anybody else. And you have answer keys, everything. Keep the answer key aside, take the paper, attempt it, then look at the answer key, check where you have gone wrong. And while you're attempting, you will come to know that, yeah, suddenly I got stuck up in this concept. So redo that concept, study that concept well. And that's how things happen. But that's later, right now. So yeah, as I tell you, so depending on the demand of the question, supply the information. So that's it. Let x be the side of the cube. If that is the case, then volume we all know is x cube. Surface area we all know is 6x squared. And lateral surface area is 4x squared. So here, but because they have asked us total surface area, so therefore we'll look for this. This is the things that we have. Since we know dv by dt, so let's go on to find out the derivative of v of v. We'll take derivative with respect to t on both sides. It's very clear, no? Because see, if you have any problem as to how the derivative with respect to what, if you have, you can just look at the unit. It's very clear to us. Centimeter cube per second. Second is with respect to time. So that way, that will give you an indication. So let's take the derivative with respect to t on both sides for volume. So what we will get, this becomes dv by dt, and derivative of x cube is 3x squared with respect to x, but the derivative is with respect to t. So that is why we have to account for it. So that way, that's it. So since it's with respect to t, we have to write dx by dt. Now let's fill in whatever that we have. This we know is 8. This they have asked us to take it as 12, and that way we will get what is dx by dt. So dx by dt, if we could transfer everything on the other side, will be dx by dt is 8 by 3 into 12 into 12. Not necessary that we should find the answer and all that, because it is later on used somewhere, so it will either get cut or whatever, or if need be, at the last step we will find the answer. We will not waste time at the step to find the answer, because we know that we have to find dA by dt. For that, let's look at the formula of A. Now, the formula of A we all know is 6x squared. They have asked us to find out the rate of change of surface area. So, with respect to t, we will take the derivatives on both sides. That way, we will get dA by dt, and derivative of x squared with respect to x is 2x. And as usual, with respect to t, so we'll account for it. So that way, this is coming to 12x and dx by dt. Now we have everything with us, so let's substitute. X for us is 12, and dx by dt we have got it as 8 by 3 into 12 into 12. This 12 into 12, 12 into 12 can cancel each other. So that is why we don't convert anything. Many a times things do get cancelled. So that's why at the last step only simplification needs to be done. And so your answer is 8 by 3. Either you keep it as 8 by 3 or you convert it into decimal. It's better to convert it into decimal end, right? So it will be something like 2.8 divided by 3, 3 2 times 6, 2 remainder, 26 times 18, again 20. So 2.66 is your rate of change of area. So rather this can be centimeter squared per second. That's it. So that's all for this video. We will be taking up the later on questions in the next video. Thank you.